So determine equations of sinusoidal graphs. We're starting with y equals cos theta. Want to use our transformation skills to sketch the graph of y equals -3 cos 2 bracket theta minus pi over 6 plus 1 on the grid. So I think let's use some words. What kind of transformations are going on here? So vertical stretch by 3. Okay, what else? So HS by 1/2. What else? Reflection on x-axis.
Phase shift right pi over 6.
So phase shift right pi over 6.
Vertical displacement up 1.
And a VD up 1. So I'm going to start with the vertical displacement just in the sense of, let's sketch the new median, right? So the new median is going to be at 1, right? So if we move up 1, then the median line moves up 1. Okay, next, and this is kind of arbitrary in a sense, I'm going to start with the y-intercept, because it's got stretches and reflections and translations, but I don't have to worry about the horizontal stretch, right? So we'll do the vertical. So vertical stretch by a factor of 3 takes it to 3. Reflection, and then there's horizontal, but we don't have to worry about that. Reflected takes us to -3. Moved up 1 and right pi over 6 puts that point there. Okay, now let's deal with our theta intercepts. And actually, we probably only really have to deal with a couple of them, or even one of them, because we know what's going to happen after that. So let's start with this one. And let's now say wistfully or that, why didn't you use pi over 12 as a scale? Because of the stretch, right? So because the stretch, this is pi over 2. This is where the pi over 2 plus n pi is where your intercepts are. Okay, so vertical stretch by a factor of 3. Reflection. Okay, and then what?
Right.
Oh no, sorry, we didn't do the horizontal stretch. So then horizontal stretch by a half, so it goes from 3 ticks to 1.5 ticks, right? And then it's got to go right pi over 6 and up 1. So it's going to end up here. Okay, so vertical stretch, reflection, nothing happened, nothing happened. Horizontal stretch, or vertical stretch, horizontal stretch takes me to here, reflection, nothing happens. Right pi over 6 and up 1. Okay, this guy here, vertical stretch, does nothing. Horizontal stretch, so this is at 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 4.5. 3, 4.5. Go right pi over 6 and up 1. So how far apart are these two guys? 3 pi over 6, right? Because they're here, they're pi units apart, right? We've done a horizontal stretch by a factor of by a factor of 1/2, so now they're pi over 2. So really, we can now fill in the rest of these, right? Starting here, you go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Go this way. 1, 2, 3, 1, 2, 3, 3, 3, and so those are all of our theta intercepts, right? I mean, if we wanted to just check that, we could take this one here and just see if it ended up there. Okay, which it will. All right, we've dealt with this guy, so what's left to deal with? Well, now we've got this minimum here, right? So let's deal with this guy. Okay, so vertical stretch by a factor of 3 takes it to -3. Horizontal stretch by 1/2 takes it to here. Reflection in the x-axis takes it to +3. Go right pi over 6 and up 1. Okay? Now, how far apart are my... So the minimums now become the maximums, right? Because of that reflection. How far apart are they? Okay, originally, but we've done a horizontal stretch by 1/2. So now they're 1 pi apart, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, and I've got this. This was this maximum, so how far apart are the maximums? So this maximum, pi, right? They're pi. They used to be 2 pi apart. Got that horizontal stretch. 1, 2, 3, 4, 5, 6. 1, 2, 5, 6. 1, 2, 3, 4, 5. Okay, and so on. Now, if I've done this right, then these guys here are going to be halfway in between these two guys, right? And this guy's going to be halfway in between these two guys. And anyway, so we can sketch it out starting and then going this way. And there we go. Okay. Now, let's just give that a shot on here. So, okay, what are we looking at? Y equals -3 cos 2x minus pi by 6. And then, what do we got to do? +1? Okay. And just because I can, I'm going to throw in y equals 1. Okay, so we should see these, assuming that's all correct. Not quite, eh? 1, 2, 3, 4. 1, 2, 3, 4.
The window the same?
Oh, right. So this is 12.
Yeah, it's not the same.
1, 2, 3, 4, 5, 6, 7, 8.
Or,
I don't know. What's
definitely different.
1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's 10.
Yeah. That'll explain it.
I tried to set the step. Let's see if I can go repeat. Apparently it didn't like me setting the step at pi over 12. Okay, so let's try pi over 6 and see what we get. One, 2, 3, 4. Okay, I don't think it cares.
What? It doesn't? Decimals let you down.
Yeah. As far as, well, it's in red too, so you know what? Let's just take out the step. I don't know, now it went to decimals. Oh, that step changed. All right, let's just say pi. All right, anyways, does it look like this?
Could be.
Okay, almost going through 0, 0 here, dropping down.
And line does it go?
Almost, a little bit.
Hey, wait, I did it right.
Okay.
Is the bumper line meant to be low?
If you graph this on your calculator, you can set the window to match with the pi by 6. Yeah, and the pi's. Each of the following. So what are the, we've already kind of done this, but what's the amplitude? 3. Why not negative 3?
It's always positive.
Amplitudes are always positive. Vertical displacement. Up 1. The phase shift.
Right.
Pi over 6.
Right, pi over 6.
Pi.
The period. Okay, either take 2 pi divided by b, or just think this is a horizontal stretch by 1/2. Half of 2 pi is pi. Okay, so the period is pi. Complete the following statements for the sinusoidal functions. The amplitude, absolute value of A is equal to the what? Stretch factor. Vertical stretch factor. If A is less than 0, then there is a reflection in the theta axis. The vertical displacement D is equal to the vertical translation. Vertical displacement is also called the, it's in the middle. Why did the Canadian cross the road? To get to the middle. It's sort of a semi-political joke.
Oh, because Canada's like a mixed
Canadians are
market.
always in the middle.
Yeah. Well, yeah, because Canada's a mixed market.
Okay. The phase shift C is equal to the horizontal, so we call the horizontal translation the phase shift. Oh, wait. Let's pause for a sec. To determine the phase shift given a graph, use a point on the basic graph that's not affected by what kind of stretch? Yeah, because what's the phase shift? It's a horizontal translation. So you want a point that's not affected by a horizontal stretch. Which point is not affected by a horizontal stretch?
0, 0.
Yeah, 0, 0. It doesn't work for the cosine. Cosine doesn't go through 0, 0. So what kind of,
Theta.
well, theta is not horizontal.
Why?
The y-intercept, right?
Yeah.
Because the y-axis is the line of stretch, right? So if we want to determine the phase shift, then if we're doing that about, we don't stretch about the y-axis, right? That point doesn't move under a horizontal stretch, then the only thing that moves that point is left-right, is the phase shift. Up-down is the vertical displacement, right? And we can see that on our original graph, right? So the y-intercept, which was at 1, is not affected by the horizontal stretch, right? It's only affected by going right. It is affected by the vertical stretch to 3 to negative 3, then right, and then there. For y equals cos theta, the y-intercept is one of the...
What's in the graph?
What kind of a point? Is it a big point? Is it a little point? So what's the y-intercept? It's a maximum, right? It's a maximum point on the graph. So it's one of the maximums. Okay, which then for us, because of our reflection, became a minimum point. Okay. For y equals sine theta, the y-intercept lies on the and the slope of the graph at the y-intercept is, so lies on the, I'm going to give it to you because it lies on the midline. And the slope of the graph at the y-intercept is, what's it doing? For sine theta, when it intercepts the y-axis, this or this? Slope is positive or negative? Positive. Positive. Okay, and the slope of the graph at the y-intercept is positive. I call that the start point. To me, that's where a sine curve starts, right? It starts at the midline going up. A cosine curve starts at the maximum going down, right? That's how I look at those two guys, right? A midline going up and at the maximum going down. So the period of y equals sine theta is, period of this, that's a horizontal stretch by a factor of 1 over.
Yeah, I think we missed something.
Did we miss something?
The period.
I don't know if
You
you
don't
have
have-
it.
yeah.
Maybe you don't.
It just says the period.
Yeah, just right here, it just says the
blank
period.
stretch factor.
Oh, okay, so an additional line. So what does it say? The period is, oh, the period relates to the horizontal stretch factor. Okay. The period relates to the horizontal stretch factor. It says, parent, don't forget to vote.
Oh, you haven't voted yet?
No, it's not following me around. It's just a notification from the Henry Wisewood app. Parent, do not forget to vote. Okay, so what's the B do? Stretches by factor of
B. 1 over B.
1 over B. 1 over B times 2 pi is 2 pi over B. In other words, the period is 2 pi over B, or B is 2 pi over the period. This you must know, right? It's not on your formula sheet. I did get it on the 30-2 formula sheet, but
Why?
it's not on the 30-1. Because you should know it just from the whole stretch idea, right? Horizontally stretched by a factor of a half, so it's a half of 2 pi, which is pi, or... So if you know the B value, you get the period. Looking at a graph, if you can identify the period from the graph, you can get the B value, right? So if I show you a graph sinusoidal, you should be able to come up with the equation, right? You're just going to look at, so, well, here's the midline, this is the amplitude, what's the period, etc. The horizontal axis scaled in degrees, then it's 1 over B, it's 360 degrees over B, or 360 over B degrees. So its period is 360 over B, or B is 360 over the period, right? If we're measuring in degrees. The value of B is blank to the number of blank in a distance of 2 pi. So we talked about this. B is the number of cycles, exactly. So B is equal to the number of cycles in a distance of 2 pi. So a lot of times you'll look at it, if the scale isn't nice, you can't tell that the period is 2 pi over 3. But if you can identify, guys, you want to teach this, then what's going to happen? If you can identify a chunk of the graph, 2 pi, along the theta axis, and one end of that is the starting point of the graph, then you just have to count how many cycles are in 2 pi. You'll get the value of B. Okay? So for example, if we go back to here, if we could just count the number of cycles in 2 pi, so from here, that'll be like 1, 2, 3, well, it's going to go, so 1, 2. I have 2 cycles in 2 pi, then the period, or sorry, the value of B is 2, right? Number of cycles in 2 pi. There's one other thing that B is, and it's a conversion from real-world units into radians. Okay, so when we start getting into, we're just up where the value is measured in hours, you need to be able to convert from hours into radians. That's the other thing that B will do. It's a conversion factor from x-axis units or t-axis units or theta-axis units into radians, because your calculator needs the value in radians, right? Okay, graph either y equals sine, cos or sine is shown below along with the graph of another trig function, the solid graph. Use your transformation skills to determine the equation for each function in the indicated form. For these, we're going to make a is greater than 0, and note b is always greater than 0. Okay? So we know we could make a less than 0, right? We just have a reflection going on. Okay, so which graph is shown to us with the dashed line? That's y equals sine theta. Okay, now we are asked to express an equation in form a sine b x minus c plus d, where a and b are both positive. Okay, where do we start? Where's the midline? So, okay, first off, what's the scale on here? It's a half, right? So one thing to really watch out for whenever you get a graph is figure out the scale, because maybe it's not 1, 2, 3, 4, right? This is a half, 1, 1/2, 2, 2.5, 3. So this goes from 3, so 1, 2, 3, 4, covers 4 units. The midline must be 1, 2. So here's the midline. If I know that, what do I know? I know d is equal to 1, right? I've got the midline. What's this distance?
Amplitude.
And what is it? 2 units, right? Half, 1, 1.5, 2. So off the graph, right? Very first thing I want to do is figure out the midline. Easy to do, right? I mean, all you got to do is count it down and say, now as soon as I said it's 4, at that point I know the amplitude is 2, but I'm going to show this, right? So d is 1, a is 2. Okay, what's next? Well, need to figure out what's the period. So here to here, the period is 2 pi. So what's the value of b? Okay, so here, amplitude is 2, that's an A. Median value is 1, D is 1, right? So like A and D, very easy to work out. B, it's not the period, okay? But the period is 2 pi, B is equal to 2 pi over 2 pi over the period, right? So 2 pi, let's write formula. B is equal to 2 pi over the period, which is 2 pi over 2 pi, so it's equal to 1. Phase shift. Is there any phase shift? No. So here's how you tell phase shift. You're looking for the starting point of your curve. The starting point of a sine curve is y-axis, midline. Okay, so you need the intersection. Where is the midline? Just go off y-axis, go to the midline, and the start point is the closest point to that going up. Okay, so close. So if it was over here, that's where it started. If it was over here, we would say it was shifted left, shifted right. This is not shifted, right? So phase shift is none, and the C value is 0. Okay, so phase shift is none, or we could say 0. So now we have y equals a. Okay, so we can write our equation now, right? Y is equal to a, which is 2, sine b, which is 1, so I don't need to write anything, theta minus c, so that's just theta.
Isn't it x?
Oh, is it x? Sorry, yeah. Sine x plus 1. Okay, now let's write it in the form. So here, what was our form? It was, let's do this. We'll do it in a couple steps. Y is equal to a sine square bracket b x minus c square bracket plus d. So that's y equals 2 sine square bracket 1 x minus 0 plus 1, okay, which then we're just really going to write as y is equal to 2 sine x plus 1. Okay, so this way we've written it in that form with the whole A, B, C, D thing. And then we're just going to simplify that form. Okay, so we're starting with the cos curve, y equals a cos b, theta minus c plus b. We're looking for a and b to be positive. Okay, midline, where's the midline? Okay, so 1, 2, 3, 4, 5, 6, 7, 8 is 4. Midline's at 0, so D is equal to 0.
You can also use the formula, right?
What formula?
You add the maximum, the minimum, and then.
Oh, yeah. Boring stuff. Yeah. Yeah, you can use the formula. Yeah. It's too much work. That's like doing math. That's why I just get to count, right? 1, 2, 3, 4, 5, 6, 7, 8. Ooh, then it's 4. 1, 2, 3, 4. There's my midline. Yeah, so D is equal to, here, let's do this. D is equal to max plus min, it's the average, over 2. So 4 plus negative 4 over 2, which is 0. And then A is equal to max minus min over 2, which is 4 minus negative 4 over 2, which is 8 over 2, which is 4. Okay, what's the period? Okay, first off, what's my scale on this axis? Because now we got degrees. So I've got 1, 2, 3, 4. So 180 divided by 4, or 45 degrees, right? Okay, so I want to go from one easily identified point to another. Okay, and I just got to count this. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 45 degrees is 360. Yeah, wow. Okay, so, wait a second. What do? We got the amplitude is 4. We got the period is 360 degrees. We got the median value is 1. What's the phase shift? So here's what you do for phase shift. Y-axis, look for the closest maximum. There's the closest maximum, right? So that's right 45 degrees, right? Right 45 degrees. So for a sine curve, I need to go midline. So y-axis midline, and then look. So as a sine curve, this is where it would start. So as a sine curve, it shifted left 45. Now, as a sine curve, is the amplitude the same? The midline the same? Is the period the same? What's the only difference between sine and cosine?
Phase shift.
Phase shift, right? Okay, so A is 4. Period is 360 degrees. So B is 360 degrees divided by the period, which is 360 degrees divided by 360 degrees, which is 1. Phase shift is right 45 degrees. Okay, so what does that give me for C? Just 45, right? 'Cause it's in the form minus, and minus 45 will take it right. And D is 1. So the equation is of the form A cos square bracket B x minus C plus D.
This one's
So you
Theta.
said E is 0.
This one's theta.
You said E is 0.
D is 0.
Oh,
Yes, you're right.
you get it.
D is 0. Okay, this one's theta. Okay, A, so 4. Whoops, put an equal sign in there. 4 cos, okay, we say B is 1, so bracket 1. Theta minus 45 degrees. Make sure there's a degree on there, right? If you just write theta minus 45, what am I going to assume? Radians. Okay, plus 0. You'll never write that, right? I mean, you might write that, but we don't actually need to write that. But this way it's written in this form, we can see we've matched everything up. So 4 cos, I don't need the 1, so just bracket theta minus 45 degrees, and that's it. That's all we need to write. Okay, so a couple more. Okay, we got sine, we got degrees, we got a scale of 1, we got 1, 2, 3, 4, 5, 6. We've got an x scale of 30 degrees. Okay, so give it a shot. You should be able to figure this out. Okay.
Yeah, let's forget the 360.
Okay, so dash line, sine theta is given. You got the solid line. So first thing, scale. 1. Scale this way, 30, 60, 90, 120, 150, 180 is 30 degrees. Midline here, D equals 0. Amplitude A is 1. Okay. Again, you can also get those from the formulas, right? Your period is 120. 1, 2, 3, 4 of these, right? 30, 60, 90, 120. Your phase shift, so again, y-axis, midline. Start point is intersecting the midline going up. That's your start point. You got a phase shift right 30 degrees. Okay, so we say amplitude is 1, A is 1, period is 120 degrees, B is 360 divided by 120, or 3.
Your degrees then.
Right? Use that. If you match that up with, oh, then there's 3 cycles in 360. So if you go 1, 2, 3, see how I see 3 cycles in 360? That should reinforce B is 3. Also, what's the other thing for B? So if the period is 120, then it's horizontally stretched by 1/3, so B is 3. Okay, your phase shift is right 30. So I need it to be minus 30 degrees, so just C is 30, it won't be negative, right? If we're going left, it would be negative. Median value was 0. D is 0. Okay, so writing it in the form, y equals, well, okay, you've got it up top, so let's just do this. Y is equal to 1 sine 3 theta, is it theta or x?
X.
X, of course. 3x minus 30 degrees, make sure there's degrees on there, plus 0. Okay, so then we're just going to write this as y is equal to sine 3 theta minus x. X minus 30 degrees. Done. Okay, y is equal to c sine 3 x minus 30 degrees. Okay, questions? Yep.
On the test, will it give us will it always give us like the sine theta graph, the cosine theta graph?
No.
Do we have to know?
Yeah, I don't know. I don't actually use it. Like, just tell me what you want. Is that I want sine theta? I think that's there just to remind you, right? So you can look for phase shift. You can just say, oh, okay, that was moved there. Okay, but the period was. I mean, to me, they could have said do this as a cosine graph, right? It's just a phase shift, right? So whether you're doing sine or cosine graph, right? The median is the median. The D value is the D value. The A value is half that distance or just a count. The period is the period. You can read that off the graph. Then the question, okay, am I doing a sine or a cosine? Because that's what comes in there is what's my phase shift. If I want to write this as cos, my phase shift is 60 degrees, right? So I have to replace sine with cos and 30 with 60, and it's the exact same. Okay, this one's a cosine curve. Okay, now, how much of the period do you need to be able to see? Half is nice, but you can get by with a quarter. Okay, here we can see half the period, right? Yeah, so you just figure that out. So let's get scales first of all. So the scale is a half. So the midline here, this goes from negative 1.5 to negative 2.5. So here's the midline. So D is equal to negative 2. What's my amplitude? 0.5, right? You're going from here to here. Okay, or you're going half the distance from 1.5 to 2.5. Okay, you can do fancy calculations. Okay. What else? Okay, I need the period. So this scale is pi. So I've got 1, 2, 3 pi is half the period. So what's the period?
6 pi.
Yeah. So the period is equal to 6 pi. What's the phase shift? 0. There is none, right? Because it starts at the maximum. So again, starting point for a sine curve is Y-axis midline, look for the peak. You look for, so here it would be actually here. If this was the sine curve, it'd be like way out here. Or it's kind of back there somewhere, but I'm not sure. For a cosine curve, y-axis maximum. Okay? So the maximum is on the y-axis. Okay, so what do we say? Amplitude was 1/2. A value is 1/2. Period is 6 pi. What's the B value?
1/3.
1/3, right? So period is 2 pi. Sorry, B value is 2 pi divided by 6 pi, or 1/3. Okay. Another way to do that, this is, so as soon as I write 1/3, I can think, oh, that's a horizontal stretch by a factor of 3. Yeah. Phase shift was none, and the median value was -2, so D is -2. Okay, now, it's a theta. So y is equal to 1/2 cos 1/3, okay, square bracket, 1/3, theta minus 0, we're in radians, so I'm not going to put a degree on there, minus 2, okay, now that's filling in the A, B, C, D, right? So in here, what's never 0? In any of these, what's never 0? B, what else? Two things are never 0. A and B, right? If A were 0, you'd be looking at the line y equals 0. And if B were 0, you'd be looking at a constant, right? Because it would just be the sine or cosine of 0. Okay, so we're really going to just write this as y is equal to y is 1/2 cos 1/3 theta minus 2. All right, I'd probably go round brackets on that. I like the one, you could write it as theta over 3 as well, right? But if you did, then if you're looking for transformations, you'd be translating it back probably to 1/3 theta, so you could recognize that as, oh, right, that's horizontal stretch by a factor of 3. Okay? So just, on these guys, just watch out for your scales. Okay, here we go. Graph of y equals sine theta is vertically stretched by a factor of 3 about the theta axis, horizontally stretched by a factor of 2 about the y-axis, reflected in the theta axis, translated left pi over 8 radians and up 4. Determine the amplitude, vertical displacement, phase shift, and the period of the transform function, and then write the equation of the transform function. Okay, so I don't know if we really determine the amplitude, because it's just kind of, so what's the amplitude? Okay, so the amplitude is the vertical stretch, which is 3. Okay? Determine the amplitude. The vertical displacement. So V vertical, so VD is up 4. The phase shift, pi over 8 left. The amplitude versus phase shift, period, and the period?
Right, left, and then say, where did you go?
Okay, is there a horizontal stretch? Okay, horizontally stretched by a factor of 2, so the period is 4 pi. Right. Was 2 pi, gets stretched by a factor of 2, so now it's 4 pi. Associated with these, then, if we're going to do this, what value of A is associated with the amplitude? 3, but then we've got this. So our A value is going to be -3. What's our D value? So D is +4, right? Phase shift. What's C? going left, I'm going to have to get theta plus, so this is going to have to be negative pi over 8. Right? Remember, the transformed form is always theta minus. So it's got to be theta minus negative pi over 8 to become plus. And what's the b value? 1/2. Okay, now, here's another way you could do this, right? We could just go through. So now we should be able to write our equation, right? So we go down here, so y is equal to negative 3 sine 1/2 theta plus pi over 8 plus 4. Okay?
Whatever it says, you have to do.
So we've taken all the information, we have listed it here, we figured out how that affects each of these values and written it down. We could also do this, right? Let's just go through. So I'm starting with y equals sine theta. It says is vertically stretched by a factor of 3. So I can write 1/3 y is equal to sine theta, right? And that's the Vs by 3. Now, we could also clean that up immediately and write y is equal to 3 sine theta. Okay? So I'm doing the transformation, old school, right? Okay, and then just cleaning it up. Horizontally stretched by a factor of 2 about the y-axis. So what's that going to be? So it's going to be 3 sine 1/2 theta, right? Because that's the horizontal stretch by 2. Okay, probably throw that in brackets. Okay, what's next? Reflected in the theta axis. So how do I do reflection in the theta axis? So you go negative y. So that's reflection in x-axis. Okay, and then we can clean that up if we like. So negative 3 sine 1/2 theta. Okay, what's next? I'm going to translate it left pi over 8 and up 4. So y is equal to negative 3 sine, okay, now we go to the square brackets, half theta left pi over 8, so plus pi over 8 up 4. Okay, then you can compare these two. So you can get your values of A, B, C, and D. This also could have said the graph y equals sine theta. So we could have described verbally what's going on. Has a midline of 4, a maximum value of this, a minimum value of that. So if you can identify maxes, mins, and midlines, then use your formulas, right? So if they tell me the max and the min, actually they didn't even have to tell me the D value, so they wouldn't have to say out 4. They could just say, has a maximum value of this and a minimum value of that. From those two numbers, I can work out D and A. Is reflected in the theta axis. They would have to somehow say that, right? And then they would have to say the left pi over 8 and up 4, right? But instead of being given necessarily this, and they could also say the period is this, right? Has a period of 4 pi. Okay, so you could have been given this information, something that leads you to get this, just give you the max and the min. From that, you could get these two guys. Okay, so that's a possibility. All right, so I think the plan for today was 1 to 5, and then the plan for tomorrow was 6 to 8. So we are done. Today's